So this is actual our VHDL syllabus starts here. I mean that, so far we have discussed about the fundamentals of the concepts of the VHDL. There are some other concepts are left and we will discuss at the time of the behavioral modeling of the VHDL. Almost we have discussed the concepts of the VHDL, and now we are entering into our the consequent units. So that is this third unit, fourth, fifth and sixth. All these are depends on only on the modeling styles. Okay, so here the modeling styles or the levels of abstraction also. So a digital system can be modeled, a digital system can be designed in VHDL at 3 different styles or at 3 different levels. So they are the structural modeling, data flow modeling, behavioral modeling, and the fourth one is the combination of the any of the previous modeling styles. So it is called as the mixed modeling here. It is called as the mixed. So combination of the any two modeling styles. So we have the 4 modeling styles. Basically it is 3 and one extra is the combination of the any of the 2 modeling styles. So out of the basic 3 modeling styles, the structural modeling is the lowest level. It is the lowest level of model. And in this modeling, the circuit is described. The circuit is described or the circuit is designed by the interconnection of the components here. By the interconnection of the components. So this is can also we can say that a gate level. In a gate level, what we will do? We will take the discrete components of the logic gates and we will connect all the discrete logic gates to form a digital circuit. Right? So that is the structural modeling. In the structural modeling, we will take the digital components and we will interconnect the digital components to get the digital circuit, logic circuit. And the second modeling style is the data flow modeling. So in this data flow modeling, it describes about how the data is flowing from the input to the output. It describes the functionality of the circuit in terms of the data flow, how the data is flowing from the input to the output. And the very important is the data flow. In the data flow modeling, we use the concurrent assignment statements. So they are arbitrary executed statements. So they are simultaneously executed statements. So if you have a 2 or 3 concurrent statements, all the 2 to 3 concurrent statements or all the concurrent statements, they will be executed simultaneously. Okay. So the data flow modeling is, it describes the behavior of the system in terms of how the data is flowing from the input to the output. Right? And the third one is behavioral modeling here. Behavioral modeling. So here the behavioral modeling is the highest level of modeling. It is the highest level of modeling. Highest level of modeling. The structural modeling is the lowest level because we use the digital gates to describe the functionality of the circuit. The circuit is represented with the components in this structural model. Whereas in the behavioral modeling, we will describe the behavior, or we will describe the relationship between the input and output by using a truth table, or by using a state diagram, or by using simply a block diagram also. We can describe the behavior, but we are not bothering about, or we are not looking about the components, what are the internal components of that device. We will just look at the truth table, or we will look at the state diagram, or we will look at the block diagram, and we will describe the relationship between the input and output. What is the output if you apply a combination of inputs to that device? And the another point in the behavioral modeling is, so we will use the sequential assignment statements. Sequential assignment statements are used in the behavioral modeling because in the behavioral modeling, the statements are executed by an order. They have an order, they have a sequence. According to that order and according to the sequence, one by one, the statements are executed. Okay. So these are the main modeling styles of the VHDL. In the VHDL, we have three modeling styles. A digital circuit or a digital system can be designed at any of the at any of the modeling style. We have three modeling styles: structural modeling style, data flow modeling style, behavioral modeling style. So hope you understand the difference between the structural, data flow and behavior. Remember that I'm repeating again, the structural modeling where we use the components to design the system. In the data flow, we use the concurrent assignment statements. Or in a simple way, you can also understand the data flow modeling as we will use the logic expressions and mathematical expressions. You can straight away implement the logical expressions and the mathematical expressions using the concurrent assignment statements in the data flow modeling. And the another data style modeling is behavioral modeling. So in the behavioral modeling, we will describe the relationship between the input and output using the truth tables, block diagrams, or the state tables. So where in the behavioral modeling, we use the sequential statements. Sequential statements. So this is about the modeling styles. What are the modeling styles in the VHDL? So as we discussed in this previous slide, so we have stated the two statements here about these two statements: concurrent statements, sequential statements. If you take the VHDL code, you will find the VHDL entity, VHDL architecture. VHDL entity defines the inputs and outputs of the system, and the VHDL architecture defines or it describes the behavior of the system. So how you can describe the behavior? By writing the assignment statements. By writing the assignment statements. So the VHDL provides concurrent statements as well as the sequential statements. We have already seen in the concurrent, in the data flow model, we use the concurrent statements. In the behavioral modeling, we will use the sequential statements. Okay, so here the VHDL provides the concurrent as well as the sequential signal statements. So example, take these three statements here. Take these three statements. So we have a signal A, signal B, signal C. The signal A, signal B, signal C. So the signal A, signal B, signal C are the output signals because you are assigning the output to these three signals A, B, C. And if you see the logic expression, if you see at the input of the three, so in the first logic expression, you have an AND operation between the A and B input. In the second statement, you have a NOR operation between the A and C input. And in the third statement, you have a single input and you are performing a NOT operation on the single input. So the moment if you observe, all these statements are, they are looks like a concurrent statements, isn't it? Right? So all these three statements are, they are looks like, or they are seems to be a concurrent statements. But the sequence of statements can be concurrent or the sequential depending on the context. What do you mean this context here? Whether you are describing the behavior of the system at the data flow, or whether you are describing the behavior of the system at the behavioral level, depending on the context in the sense, the style of modeling. Okay, depending on that, The statements which are in the architecture body, they will be concurrent or the sequential statements. Example, if you take, if all these statements are, so we have taken a 3 statements here, signal A, signal B, signal C. These 3 are the statements. And if you place these statements in the architecture body, they are known as the concurrent signal assignment. So this type or this way of using, we will be using in the data flow modeling. Okay, and the second one is, if these statements are appear or if these statements are placed in the process statement. At 2 we haven't discussed about the process statement. We will discuss about the process statement in the behavioral modeling. So if all these statements are placed in the process statement, then they will be executed sequentially. They will be executed sequentially. They will be executed in the sequential. So here, in a easy way, in a simple way, you can understand that always in the data flow, we use the concurrent statements. Always we use the sequential statements in the behavioral modeling, because in the behavioral modeling, we use the process statement. We will modeling the digital system using that process statement. So that's why straight away we can state that the concurrent statements are used in the data flow modeling and the sequential statements are used in the behavioral modeling. Remember this. ఎక్కడ మనం కాంకరెంట్ స్టేట్మెంట్స్ వాడతాము, డేటా ఫ్లో స్టైల్ మోడలింగ్ లో కాంకరెంట్ స్టేట్మెంట్స్ యూస్ చేస్తాం. సో వేర్ వీ కెన్ యూస్ ది సీక్వెన్షియల్ స్టేట్మెంట్స్? The sequential statements are used in the which one? Behavioral modeling style. Remember this. So basically there are 2 types of the assignment statements: the concurrent assignment and sequential assignment statements. So now in today's we will discuss about the data flow style of modeling. Data flow style of modeling. As I said that, as we discussed it, that the data flow modeling, we use the concurrent statements. Concurrent statements are arbitrary executed statements. And here in the data flow style of modeling, the statements are divided into 3. One is simple concurrent statements, with select statements, when else statements. Simple concurrent statements. So simple concurrent statements means we will use a sign assignment operator. Symbol is this one. So see this symbol, which is nothing but less than or equal symbol, right? So this is used as a sign assignment operator. A sign assignment operator. So we will use simple concurrent statements. In these simple concurrent statements, we will use this assignment operator. And in the with select, so we have a predefined syntax there. So we will use that syntax for describing the behavior of the system in the data flow style. Similarly, in when else also we have a syntax, a format. Using that syntax, we will describe the behavior of the system. So now we will see the first one, we will see the syntaxes. Then we will go for an example, how to write a VHDL code using these 3 statements. So there are 3 types of the statements we will use in the data flow: simple concurrent statements, with select statements, when else concurrent assignment statements. So దీన్నే మనం ఏమని చెప్పొచ్చు అంటే, the with select is known as the selected assignment statements. Selected assignment statements. Selected assignment statements. Whereas the when else is said to be conditional assignment statements. Conditional assignment statements here. In a terminology, so we will say that simple concurrent statements, selected concurrent statements, conditional concurrent statements, right? A selected consists of the with select, a conditional select the when else. A simple concurrent statement consists the assignment operator. So we will see the syntaxes for these three. So here a simple assignment statements. A simple assignment statements. So simple assignment statement is used for logic or arithmetic expression. So you can straight away, you can implement a logic expression or a mathematical expression using this simple signal assignment. The syntax is also very easy, simple one. So see this, the syntax is here, signal name with the assignment operator. This is called the simple assignment operator, this symbol. And you will have the expression. Expression in the sense you will have a logic expression or you will have an arithmetic expression. Okay, so this is a VHDL assignment operator. It is very simple. So here see an example for a signal name A. Let's say the A is a signal, and you can assign an expression value to this A. So now what is the expression? Take take an expression as the B ORed with C. This is expression. Let's say this is expression. Let's say this is expression. So what you are doing here, the B and C inputs are logically ORed, and the value of this OR operation is assigned through A by using the assignment operator. This is a simple assignment statement here. And you can also give a logical expression such as like A plus B plus AC plus BC. Take this is another logic expression. So you can also straight away you can implement this logic function by using this simple assignment operator. Okay, so this is a simple assignment statement. And the second one is the with select. So the with select is a selected assignment statement. Sorry, a selected assignment statement. Just a second. Am I sharing the screen?
Yes, sir.
So next with select అంటున్నాం. So with select లో ఇక్కడ మనం ఏం చేస్తామంటే అక్కడ మనం actually in the previous one we have a simple assignment operator by you can straight away implement the functions here. Okay, but in the with select, see this is the syntax here, with select syntax. So you will have a keyword with expression with select. With expression, expression is a user one, user defined one. He can give the expression value or he can specify a signal also. Then see, after this select with expression select, you have a signal name which is maybe your output signal, and to this output signal we wanted to assign a value from the different selection values. You will have a range of values. You will have a range of values. When a particular value is given, that expression value output is assigned to the output signal. For example, you have a constant value of 0, 0, 0. Say you have a constant value of 0, 0. For this constant value, you have a logic expression A, B ankondi, for example, A, B. So you will have A input and you will have B input. When 0, 0 is the input, So the AB is the expression output. AB is the output now. Let's say AB are the 1 and 1 inputs, and you have a constant value it is also an input 0 0. So for this value, this expression AB value is assigned as the output. And the second expression you can take, the second expression 0 0 1, say. The second possible combination is 0 0 1. And for this, you can assign some other value to the signal, output signal. So all these are the expressions when a constant value, or you can have a choice of input value. So we will see example. Just remember that in with select, you will start with an expression select, and depending on the given input, the corresponding output expression will be assigned to the output signal. This is about the syntax with the with select. Okay, in this what you will have a constant value, a user choice value. When that value is given as an input, so the particular logic expression value assigned as the output. Okay. And the third one is when else. This is the conditional. So in the previous, you are selecting one of the value as a output. From you have a range, from that range, you are selecting one value. So that is selecting assignment signal. And the other one is when else. This is the third type. In the third type, see the name when else, conditional. You can understand conditional. So if there is a condition meets, then only the output will be assigned. If the condition is not meet, then some other value is assigned here. So that is when else. You have an, sorry, so ignore this one. So package body is not there. Ignore this. So ignore this. This is not there. Ignore this. Ignore this. And let's see the when else. So when else, it is just like a case in the C language. You have a if case, if else, right? If else, if condition meet aite if condition meet kakpote else. So same one here also we will see using the when else. So here we will have a signal to which you can assign the output. When the logic expression meets, it will assign a value. If the logic expression not meets, you can assign this some other expression. Likewise, you can have or you can give a group of statements to implement or to describe your digital system. Okay, so this is the syntax to the when else here. So now we will see an example to each three statements. So okay, we will see the example. Okay, so just a second, I will share a Word document. C3, Emma C3 unnara Divya? C3 Divya, Emma unnara? C2 Surya. Am I audible? Am I వినబడుతుందా నా మాట మీకు?
Yes, sir.
So now we will see an example in the data flow modeling style. So here the example is design of full adder using the VHDL. I mean that design of full adder using data flow style or data flow modeling style. Data flow modeling style. So as we know, what is a full adder here? So a half adder circuit, it adds the 2 binary bits. A full adder circuit, it adds the 3 binary bits. The third input is so a binary input is it adds the 3 binary inputs. A full adder adds the 3 binary inputs. So between the 3, this one of the input is the carry in. A and B are the real inputs. C is the carry in, which is forward or which is carried out from the previous sum. And there is a outputs sum and carry. We have a sum and carry here. Okay. And now if you want to describe or now you want to model a digital system, which is a name as full adder circuit. Full adder circuit. So first we will start with the block diagram because it is the higher level for to any digital system, highest level. So we start with the block diagram. So if you take the block diagram, first we will represent the inputs A, B and C. The number of inputs are 3. The number of inputs are 3 and there are 2 outputs, sum and carry. There are 2 outputs, sum and carry out. There are 2 inputs, sum and carry. Okay. And now here, a full adder circuit, it adds the 3 bits of input and it provides an output such as a sum and carry. So since it is having the 3 inputs, the possible combinations of inputs are 8, 2 power 3, 8. So they are from ranging from 0, 0 to 0, 0 to, they are all ranging from the 0, 0 to so they are all ranging from the 0, 0 to 0, 0 to all ones here. So when a corresponding input is applied from 0, 0, if you apply, so there will be a sum and carry output. So based on the combination of inputs, you will have the output sum and carry. So for 0, 0, 1, the sum is 1, carry 0, 0, 1, 0, sum is 1 and carry 0. When you have the 2 inputs are 1 and 1, the carry is 1 and sum is 0. And likewise, when you have it, all 3 inputs are logic high values, you will have the sum and carry are the 1 and 1. You will have the sum and carry 1 and 1. So now, how we can implement this full adder circuit in the data flow modeling style or at the data flow modeling style. So for that, we can directly go to the logic expressions. We need not to go for the truth tables here because if you know the logic expressions, if you know the logic expressions, you can directly implement the function here. So now, even without the truth table also, we can straight away give the logic expression for the sum and carry out. What is the sum of a full adder circuit? A exclusive, B exclusive, C, if the inputs are A, B, C respectively. And the carry out is AB and AB or BC or AC, which is simply an expression AB plus BC plus AC, right? So now if we want to implement, if we want to write a VHDL code at the data flow modeling style, so even the circuit is also not required for the data flow, but we have considering the circuit too, how a full adder circuit it is there. Okay, so we have considered the block diagram, we have considered the truth table, we have considered the logic expressions and the circuit also. But out of the 4, the logic expressions are sufficient to write the VHDL code at the data flow modeling. We need not to have a truth table or the logic circuit. So now we will see here we will see the VHDL code. So for writing of the VHDL code, first what we have to declare? We have to declare, we have to declare the libraries here. So we know what is a library. A library is a collection of packages here. So first we have to declare the the library. So we are taking the standard library, that is library IEEE, and in that we want to use packages. Which package we want to use? So it must be specified here. So that is use IEEE dot, which type we are using, this standard logic 1164. So std underscore logic underscore 1164 dot all. What is this dot all clause? When you use dot all clause, which means that we wanted to use all the items in that package. We wanted to use all the items in the std logic 1164 package. So these two are essential. You must be specify these two. When you are started to writing a program, you must specify the library and you must specify the package. Okay, you must have to specify the packages here. Then, and the next one here, we wanted to write the entity here, because a VHDL program consists of mainly two things: entity, architecture. Internally to the entity and architecture, you will have the different things: entity declaration, architecture body, package declaration, package body, configuration declaration. These are all comes under the entity and architecture. But externally, we will see that entity and architecture only for a VHDL code. So now how to write the entity here? So for this, we use keyword entity, and here we wanted to design a full adder circuit. Therefore, I want to give a name as full adder is the entity name. Entity name is here full adder circuit. Okay, full adder circuit is. And after that, what we have to do here, we have to declare the ports here. What are the signals we wanted to declare? You can declare in the entity here, entity. So now in the port, from the diagram, if you see, or from the logic expressions, if you see, what are the inputs here? A, B, C are the inputs, and the outputs are the sum and carry out are the outputs. So therefore, we will declare the A. We will declare A is a signal, which is a mode of the input, and the type is standard logic. It is a type of the standard logic. The A is a signal, which is a mode of the input, and it is the type standard logic. Why I am using this standard logic? Because I am using the package standard logic 1164. Okay, and declare the second signal. The second signal is B. So you can declare it B, which is also input signal, and it is a type of standard logic, right? And how many inputs are there? 3 inputs. So now I am declaring the 3 inputs here. C, which is also a signal, input signal, and the type of the signal is standard logic. So now I have declared the inputs here. I have declared the inputs here. Now what about the output here? Outputs here. So outputs are, there are 2 output signals. Entavi logic expression nunchi meer observe cheste sum and carry out. So now take the sum. So define the sum here. So sum is a signal. Sum is a signal. And what is the type of mode? Output. And the type is standard logic here, which means that the standard logic will have only 2 values, 0 or 1. And what is the another output signal, which is the carry out. Carry out. In a short form, I am writing it as C out. Okay, now? So we are writing it as C out here. Carry out, which means the carry out. What is the mode here? Output, and the type of signal is standard logic. Should I place the semicolon here after the declaration of the last output signal, or should I keep this signal out of the bracket? So it should keep after the bracket here, right? So this is called the entity declaration. So this is called the entity declaration. So in the entity, we have started with the entity name is, and you're using the port is a keyword to declare the input signals and output signals. Input signals and output signals. So here, these are the input signals, and these are for our understanding purpose I am giving. So these are the outputs here, right? And after, so we have done the entity here. Now we have to write the architecture of the program where you're describing the behavior. Okay, so the architecture starts with the, and sorry, you must end with the entity here, and entity with the entity name. What is the entity name here? Full adder. So this is entity here. So so this is entity here. This is all for the entity declaration. And the next one is architecture. So architecture, name of the architecture. It is also user defined. So I am giving data flow for our easy understanding purpose. At what level you're describing the architecture? Data flow. So that's why this is the user name I am giving here. This is the user name and architecture name. This is the architecture name. Data flow of entity name. What is the entity name we have given in the entity? Which is full adder circuit. Which is the full adder circuit. Which is a full adder circuit here. Which is a full adder circuit. Full adder circuit. Full adder circuit is so ikkada next em cheyali ippudu manam we will write the architecture. So if you want to write the statements inside of the architecture, we will start with the begin. After begin only you have to write the statements here. Remember this, after begin only you have to write. Okay, so for that, so you can, since it is a data flow modeling and you're using a simple concurrent statements, so you can directly write the sum. You can directly write the sum as an expression. So what is the expression that we can have here? So here, see, you can directly take this expression here, sum. You can directly take this and you can assign this it here. So now see, so what is the output value of sum? It is the functional value of A exclusive or B exclusive or C. And what is the second output? The second output we have assigned in the entity is C out, which means that carry out. Carry out. Sorry. Carry out. So now what is a carry? We know the logical expression of a full adder circuit is, we know that it is a logical expression is AB plus BC plus AC, right? AC, that is the carry in. C stands that carry in. These two are equivalent only. It is in the form of logical expression. It is a mathematical expression. Same. So now you can directly take this expression. I mean that you have to assign this expression. So you have to assign this expression here as a output. Here. So you can assign this as a output. See this, and terminate with the semicolon. So this is the simple way of writing a full adder circuit at the data flow. So now we wanted to end the architecture here. And architecture name. What is the architecture name? Data flow. Architecture name is data flow. Architecture name is data flow. Architecture name is data flow. Okay, so this is how to write a VHDL code. See this one. Visible hai kada idi? So This is a VHDL code for the full adder circuit in the data flow style. In the data flow style.